Good afternoon, everyone. I know it's late in the day. You probably have your brains fried at this point, and you will also have to kind of find a map to get to this room. Thank you for being here. I'm going to talk about the last mile. I know it's a cryptic term. Some people told me that. Essentially, the topic will be once you migrate or upgrade to a latest version of SQL Server or to Azure SQL Database, is it over when you turn the dial? Is it over when you cut off the application from the old database to the new one? It's not. And that's what we're going to talk about today, the challenges that you're going to face there. Housekeeping first, silence your phones, a lot of stuff from past to explore. My name is Pedro Lopes. I work in the SQL Server team. My area is the relational engine, so it's query processing in essence, and also performance. And yes, what comes after migration has a lot to do with performance, and that's what I'm going to talk about today. So this is part of a learning pathway. How many of you have taken the previous courses of this? Quite a few. Good. They all build on each other for the most part. At least mine builds on Pam's, which was the previous session, where she described the process we recommend for you to move from an older version of your SQL Server to migrate, modernize to whatever is the newer version, either SQL Server 2016, 17, 19. We have quite a few customers already in production with SQL 2019, and obviously Azure SQL Database. Just to get one thing so they're all on the same page, Azure SQL Database and SQL Server 2019, SQL Server as a whole has the same database engine, which means that it's just a platform change, but it's not a database engine change. So this is the agenda for today. I'm going to talk about something that we've been calling the compatibility certification that Pam alluded to in her session briefly. We're going to talk about a little bit what that is, and then we're going to dive into details, because here's the thing, with any proposal that we have, there's always fine print, right? In the sense that there's always things you need to take care of. Nothing comes for free, and it's upon you to know what this means in detail, so that you can take action during a migration or post your migration. And then we'll really dive into what again, in our view, needs to be done after you've flipped the switch to use the new database. And finally, a breakdown of all the tools that we've built around this migration ecosystem, some of which Pam mentioned, but then I'm going to add one more at least that will help you in this final stage. So let's talk about database compatibility certification. One thing I'd like to get clear is that the name may imply it's a Microsoft program. Oh, I sign up somewhere, and Microsoft certifies my database. That is not quite the point. It's actually the opposite. It's, as I'm going to describe, it's a proposed method, if you will, for you that own databases, even for independent software vendors, so to be able to certify your application, not based on a concept of a named version or a platform. Because remember I said a few minutes ago, we have the same database engine across platforms, which means that in our mind, it makes less and less sense for you to think about, oh, my application was certified for SQL 2008 or for SQL 2014 or 16. So therefore, I need to engage in a lot of testing to recertify the application to work on SQL 2019 or to work on Azure SQL Database. And we propose that's not exactly the case, and let's go into some detail on that. So the gist of this is that you would need to certify once and then run anywhere. How? That sounds too good to be true. What do you have hiding there? The ability to move from a SQL server, typically a more legacy SQL server like 2008, for example, that went out of support in last July, to a newer platform, that's the paramount idea here. You move to a new platform, and foreseeably there's no code changes potentially that you need to make. You just move the database there, and it just works. There means, as you see, there are two paths. You go up to the cloud. You still leverage on the other path, you still leverage your data center investments with your SQL Server on premises, but it's the same engine, so you just move wherever you want to go. Now, this has a few benefits associated with it. If you start thinking about a method to modernize my database, irrespective of platform, irrespective of a named version. And the first one is that you can have a unified model of certifying your application. For example, if you're an ISV, you state when you finish building your platform, your application, you test your application in whatever is the given version that exists of our product, SQL Server or Azure SQL Database. And you say, okay, I've tested this database and this product is certified to work on something called the compatibility level, blah, blah being a number that matches to a version. Now, why is this important? Historically, every version of the engine that we released comes with at a database level, comes with a config setting that's called the database compatibility level. What it does, in essence, because I'm going to talk about that in a few minutes some more, is that it forces the engine to behave with the rules and regulations that it had in that version that was released. Which means that, let's say I built my application to work on SQL Server 2008. What I actually did was I built my application to work on a compatibility level called 100. Now, this means that you can actually take that database, move it to Azure, move it to SQL Server 2016, 17, 19. You keep that setting as is, because it doesn't change automatically. It's something that you would have to do anyway. If you don't change it, that database, the code that runs inside that database will behave the same way as it did in your 2008. So you point your application, it should just work. And that's the gist of database of compatibility certification. You certify on a compatibility level, which is technically what you've always been doing, just not on paper. On paper, you've always seen a name there, a name of a product. So without the name, but just with the technical certification that you've made based on that setting, then you certified once, and you can perfectly allow your customers, for example, to, if let's say you didn't release a new version of the application that works in SQL Server 2019, for example, or you are an end customer and your ISV is no longer around, and you have this database and this application that worked with 2008, what do you do with it? Right now, SQL 2008 is out of support. What are your options? You still need that application to work. That's when you move to a higher version of the engine, which brings you a lot of benefits that I'm going to talk about, but you still keep that setting that ensures that your application code behaves the same, which is in essence what you want to do. But then it also reduces upgrade risks. Because when you know that you've certified based on the technical setting, not on the name, you know that when you move to a newer version of the engine or move to Azure, you can decouple moments of migration. For example, you have a large ERP system that you need to modernize. Move from an old version of SQL to a new version of SQL, and at the same time, upgrade the application itself. I've been involved in a few of these migrations, and it's usually very carefully planned, as it should. And alas, you may have to modernize at the same time the database layer and the application layer. That is an added risk, because if something happens just after you supposedly complete the migration, there's a huge surface area where a problem may be. You don't know if it's the application interacting with the database, if it's the database itself, if it's a problem with the data and the application doesn't recognize the data that was probably converted. So imagine that you can separate these two moments in time. You can, for example, move the database to a newer version of the engine, keep the database compatibility level, and point your current application there. Now, if you have some problem after after you point the application to the new engine, then, well, you have a much narrower surface area to troubleshoot. And if you have a problem there, because you kept the same DB compat, so what you were saying is that it needs to work the same way, and if it's not, guess what? You open a support case. We'll help you because it's supposed to work. And then you, at the later time, once you've stabilized the database layer, you move the application layer. And again, if any problem arises there, guess what? You know what was your last variable. It was the application layer. So that's where you started troubleshooting. So that's about reducing the upgrade risks. And that means that you are free to move to always modernize the underlying database engine that you use without necessarily needing to modernize and therefore recertify your application. In newer versions of the engine, we have added a number of features that improve scalability and performance of the system as a whole without necessarily having to upgrade DB compat, which is another myth I'd like to dispel. How many of you have moved from SQL 2008 to a newer version at some point in your careers? Okay. How many of you have immediately flipped the DB compat level to the latest available? Okay. How many of you did that post SQL 2014? How many of you had pains after that? There you go. So let's talk about that later today. But I would advocate for a non-kamikaze way of doing that. So that's the gist of database compatibility certification. So the ability for you to move from an older version of the engine to a newer version, and it's not maybe up to you, up to your team, or maybe you don't have the funds now to start a project to recertify your application. You just wanted to leverage a new engine, maybe for support purposes, maybe because you have a new feature in the engine that you would like to leverage, but it's dangerous to upgrade DB compat because that will change a number of fundamental aspects in the engine that we're going to dive a lot deeper into today that then lead you to a poorer experience. So, if you move from SQL 2008 to SQL 2016, for example, or a higher version, immediately you leverage a few things just out of the box without changing anything in the database. You leverage something called AutoSoft NUMA. That's our ability to recognize the architecture of the system that you actually deployed your SQL into and make improvements into memory allocations and CPU usage allocations through scheduling. And you don't have to do anything. If you move to SQL 2019, you are able to leverage accelerated database recovery. That has nothing to do with the database compatibility level of the database. It can still remain at 2008 level. And there's a number of scalability features that are just there, and you leverage them because you move to a new version, or Azure, and not because you had to recertify your application. So what we call a database compatibility level protection, which is something we stand by, and by the way, there's a link there if you want to read a lot more about details about this proposal, if you will. It has to do with a few things. First of all, we protect you by maintaining backwards compatibility. Yes, you move to a new version of the engine, but by maintaining the DB compat for whatever time you need, if you ever need to recertify the application, then you're saying that I want to maintain the same behavior in my code that I had back there. And we protect you against that, against changes. And that leads you to predictable performance. Because another aspect is that you move to a new version of the engine, but guess what? You don't want surprises. You don't want your workload to start regressing and getting into, you don't sleep, you start going to work every day, 12 hours a day to try to fix something that inadvertently was introduced by flipping that switch, flipping the database compatibility level. And that's because under the compatibility level, there are a number of features that may affect performance that we've gated purposely. Because it all has to do with stability. So we want you to move to the new version of the engine, but we don't want to regress you. So please keep the DB compat as is until you're able to test. And there are a number of ways to do that we're going to discuss today. And the last one has to do with how you do that validation. So if you come to a point where you choose to move to a new DB compat level, because you now have the time and manpower to go and retest your application, actually recertify it. Probably you want to use the new intelligent query processing features or others that are under DB compat. that's when you give you a number of tools to help you make that transition, but also to help you move and stay on the same compat level. We also provide other tools for you to certify that it's safe for you to do that. And this talks to our stance on maintaining DB compats. So if you notice for a few versions, our stance on DB compat was when you move to a higher version, you should maintain the DB compat only for whatever short period of time you need, and then please move to the higher compat level. And that's probably why many of you have this reaction of, I moved to the new engine, I need to immediately upgrade DB compat. And then I'll deal with whatever comes after. Well, if you notice, starting with SQL 2014, we stopped deprecating and actually removing older DB compats. So if you look all the way to the right in Azure SQL Database and SQL Server 2019, you can still move a database back from 2008 all the way there and maintain DB compat, and we fully support you. And we have no intention of further deprecating compat levels. Footnote here, if by any stretch of the imagination it comes to a point where to evolve something fundamental in the engine we need to deprecate a feature, we still will. But database compat or everything else, we have stopped deprecating components long, long ago. And that results in this, in for your ability to modernize and maintain a level of predictable performance and predictable behavior. Okay. So what happens with new developments, with new work? Do you still want to keep the old DB compat? No. If you're developing a new application on a new version of the engine, by all means, start with a new DB compat level, with the latest available, which gives you all the, for example, the intelligent query processing features just out of the box, and a number of other improvements that we've made into the engine that I'm going to discuss more about that become default when you upgrade DB compat. So in essence, all new work needs to be in the new DB compat. Migrating an existing application, never move the DB compat immediately. That's the gist of this. But I said there's a few things you need to take care of, right? There's always fine print, there's always details. So let's look at what those details are. This is probably why you will want to run the DMA tool that Pam talked about before you upgrade from a DB compat 100 to a higher version. Even before, like Pam showed, even before you move the database from, let's say, SQL 2008 to a newer system, you ran this tool. And this tool, if you recall, gave you insight on whether you had, for example, blocking changes, like discontinued code. Discontinued code means removed from the product, so it no longer works, and you need to know about that before you move, because if you move a database that has code inside that we've literally discontinued in a very old version, then it simply won't work. Like I said, we stopped doing that in the latest versions, but if you're coming all the way from 2005, 2008, you may encounter those scenarios. So again, what is a DB compat then? The DB compat is a setting that will protect your database from two things. One, it sets a database, it's not a server-wide setting. It protects it's a database level setting. So each database may have a different setting in the same server. It forces the engine to behave in a way that's compatible with whatever source version you chose. So if I'm coming from SQL 2012, that's 110 compat level, as you see in the screen there. If I move that all the way to 2019 or to Azure and I maintain 110 compat level, I'm telling the engine, hey, this database worked well with SQL 2012. It needs to work well with the new version, and that's what I want you to do. And so by doing this is the gist of database compatibility certification, is that you will be in control of what happens inside the database with the code that you wrote for your applications, instead of the engine being in control of that. Now, the DMA application did come up, for those that were in that session, did come up with a few categories of recommendations. We had breaking changes, if you recall. What are breaking changes? Breaking changes are changes in behavior, meaning Your code still works. So literally the transact SQL code that your application is sending to the database still works, still executes, but it may have a different outcome. That's dangerous, right? So imagine, for example, that I have this expression, this cast expression here. And you see there that if I use a DB compat 120, which mapped to SQL 2014, or lower, I had the result you see there in the top row. So January 1st, 1900, and the precision went all the way to the milliseconds, right? But in SQL Server 2016, by default, under what we call the default compat level, and just to clarify that, what is the default compat level? The latest available in every version, it's a default compat level, which means if you create a new database, that's the compat level with that database is created. But for every database that is restored or attached or whatever, it retains the previous compat level. So that's why you call it default. Okay, so in this example, my code still works, my declare and then the select works, but then as you see, depending on the DB compat level, it has a different result. Now imagine that I'm using this data to run a query that has an equality predicate, where column 1 equals a constant which has that value over there. Sorry, this value over here. And then suddenly you move to SQL 2016 or above, you move to the highest compat level, and your application and the conversion starts yielding this result, which has added precision. And suddenly your equality predicate no longer works because it's no longer equal. It's literally a different precision number. So this is just one example of a few precision changes also happened with date and time data types back in 2016 in the default compat level. So it's yet another thing you need to take care of is knowledge is power. And by running the DMA tool and by going to a link that has a script that I have in the notes here, you're able to know beforehand, before you bump up DB compat, if you would be facing these issues. Because you don't want to find out about code conversion differences weeks or months after you put your application in production, the new DB compat level on the new server, and then suddenly you have real problems that you actually don't know how to solve. So again, knowledge is power. You need to know everything you can beforehand. Now this is about breaking changes, which DMA warned you about. There's another, there are other breaking changes that are not protected by DB compat. So the first one, because I didn't mention this part very specifically, if you maintain the older DB compat, even in the newer version of the engine, you maintain a behavior that you expected when you first certified and built your application. If you move to a higher version of DB compat, then you change behavior, and you might not have accounted for that. So that's when you need to recertify. Now, there are other aspects of breaking changes that are not protected by DB compat. For example, that's expression there, select date part. And this is for those of you that are still running 2000. Is someone still running 2005? Okay, I feel for you, but I understand. I feel, but I understand. So for those of you that are still looking at one day modernizing those SQL 2005 databases, the 90 compat mode, which was the default compat mode in 2005, no longer exists. And that's been deprecated, that's been removed from the product many years ago. So if you move those databases to SQL 2008, sorry, to SQL 2012 or any version above that, your database would be automatically upgraded to the minimum compat level that exists in those versions, which is 100. But look here. If that expression runs fine in the DB compat 90, but in DB compat 100, so just after you reattached, restored your 2005 database to 2008 or above, it no longer works. So imagine that you want to move that 2005 database nowadays to 2017, 2019, you'll face the same issue. The minimum compat level that exists there is 100, so you would face these errors here. You need to, that's a case where you really need to convert your code. And the example of conversion is right there. So again, all these are output by the DMA tool. So it's very important for you to proactively run these tools, especially when you're coming from a very, very old version. If you're coming from SQL 2012 or above, if you go to the documentation, we've hardly removed everything. And since 2012, we haven't removed anything. So you're safe when from that perspective, from a DB compat perspective. If your database today sits in SQL 2012 or 2014, and it works, you move it now to 2016, 17, or 19, and you keep DB compat, it will work. And when you run the tool, you still run the tool, but it won't show you anything that you need to change. But I can't stress enough, if you're coming from a very, very old version, you will face these issues. So always run the tools. Okay, so these are breaking changes, but that's not the sum of everything that you may find that moving from a very old version to a newer version may afflict you. The other one has to do with deprecated code. Now, deprecated code, I know it's a very loaded term, but it's just a way for us to tell you, hey, we're no longer investing in this feature or language expression, so there's replacements for this. When it comes a time that you need to refactor your application, or if you're building a new application, don't use these deprecated features. It's just telling you that they're parked, if you will. They won't block your upgrade. Deprecated code will still work in the new version, okay? So that also is output by the DMA tool. I need to tell you about it here because it's still protected by DB compat. It's just something you want to look at the next time you refactor your application. But now we also have discontinued code, and this is the real showstopper for you. If you have discontinued code, that means it was removed from the product. There's no DB compat that will protect you because it simply doesn't exist in the product anymore. So, and again, the DMA tool identifies if you have objects that they may have this. For example, in SQL 2012, the system sort procedure SPDB option was removed. In SQL 2012, which again, it was the last version that we removed a few things from the product, the hint fast first row was removed. So even if you keep the SQL 2012 DB compat level, when you upgrade your current SQL 2012 database to a newer version or to Azure, this needs to be addressed because the code that invokes these two, and there are a few others, T-SQL notations will no longer work. But there are changes. There are replacements for the SPDB option. You will change that to an altered database configuration. And for the fast first row, that was actually replaced by a new code notation, which is fast, and you specify the integer number of what's the number of rows that need to be returned first by your result set. So there are replacements. We're not leading you to a dead end, but this is something that will simply not work in the newer version, even maintaining DB compat, that you need to know about and to do something about. All of this, the DMA tool helps you. So it's very, very important that before any migration, before moving any old database to a newer version of SQL or Azure, even if you don't move DB compats, you need to know about discontinued features. Those need to be addressed. Those are blockers. And then you need to know about, what's the other one? Behavior changes. And those may or may not be important for you, but you need to identify them to then make a call. Is this important for me? Is this not important for me? And then go ahead. Okay, and this is just an example of the UI of DMA. And as you see there, alas, that's not very visible there, but you have a few tabs with the compat levels. This was coming from 2008, and we see that we have a few categories there. The top one being breaking changes, and the second one being behavior changes. And in this case, I don't have discontinued code. So the breaking changes in this case is the ones that I need to go and review each one to see how they affect me, and then make a call. Is this something that I will refactor my application right now? Or if I don't, then breaking change means that it's a showstopper. Okay, so again, knowledge is power. Always use the tools to uncover this information before you run into nasty surprises when there's no rollback possible. Okay, but what else is under DB compat? So I've given you, yes, there's a question there. Go ahead.
Is there a way to share this?
Oh, yes.
Be able to share this with developers, but it seems to be run it on your machine and that's it.
Excellent question. So the question is there a way to share this? This is not in this screenshot, but if you use the latest version of the DMA tool, which I believe it was just released to actually include SQL Server 2019 support, it now has an export button. It's right there? Oh, okay. So, and this is already 2.6, okay. I'm sorry? It had, oh, now it has the save. Now it also has the save, okay. Now you can save and reopen later. So, okay, so you can share this as an Excel file with your developers and they will go at it. Okay, so I've given you a somewhat grim picture. I understand that, but now let's track back up. So what other changes are under DB compat? And those are the ones that may have given you grief. Assuming that all your code worked when you cowboy style just upgraded DB compat and all your code worked, from a functional perspective, but then you found performance issues, this is where they lie, and this is the other things that are tied to the database compatibility level setting that you need to know about, because those will influence your decision of when to move or when to stay put. So query optimizer fixes under trace flag 4199. Who here knows what trace flag 4199 is? Okay, a few. In essence, for many years since we've had the product, there are bugs like in any software product, and like in any software product, we fix those bugs. Now, you may install your cumulative updates, your service packs in previous versions, and code fixes are just enabled by default, and you leverage those code fixes. One exception. Code fixes made to the query optimizer are never enabled by default in any version. So query optimizer fixes that we've released throughout the years have always been under, or after a certain time, have always been under a trace flag 4199. You need to enable trace flag 4199 in order to enable those query optimizer fixes. And along the versions, there's quite a few. That means that were already, for example, if you were in the SQL Server 2008 and running with trace flag 4199, you are leveraging with any update, any cumulative update that you add to your system, you are automatically enabling those fixes. If you don't have 4199, you're not. Is that clear? Good. Okay. So what happens is, after SQL Server 2016, we have looked back and said, we have quite a trail of fixes made to the query optimizer that have been very, very useful for many customer workloads throughout the years. And a lot of customers are not leveraging those fixes and those enhancements because they are under the trace flag. So let's turn them on by default. Oh, but if we turn them on by default, then, I mean, we just talked about a number of things that can go wrong. We can't cowboy our way, just turn on trace flag 4199. So what we did was, if you move to a higher compat level, 130 or above, all the query optimizer fixes that have ever been released in previous versions will become enabled by default. That's another change right there. Now, I personally have never seen a problem with a query optimizer fix being enabled and then translating into introducing a problem, but because the possibility always exists, there are billions of workloads running out there in SQL Server. We can't possibly test them all. That's why we have this conservative approach. We don't enable by default. So you'd have to move to the new compat level to leverage all the previous fixes. And then, like it happens in every version, we find other bugs that we address. Those new bugs that are released after the RTM day, those are again under 4199. So let's, a little bit of quick history. 2016, we did this. What happened in 2017? Every query optimizer fix that was released after 2016, up until we released 2017, got enabled by default, rolled up, got enabled by default when I moved to database compat 140, which maps to the default of 2017. 2019 released this Monday. What did we do? We rolled up all the previously released query optimizer fixes under 4199 by default, For databases that you move up to database compat 150, and so on and so forth. That's our model now. So that's one thing that's under that trace flag, and that's one thing that you enable by default once you move db compat. So that's one of the variables that you introduce if you just move db compat without taking care of what can go wrong. And the others have to do, someone mentioned CE, yeah, there you go. So you mentioned cardinality estimator changes. Yes, the infamous cardinality estimator changes made to the model back in SQL 2014, and made ever since, by the way. Every version we release, there are numerous changes to the cardinality estimator. But, again, why it's so important for you to move to a new database system and maintain db compat, these changes are only enabled when you bump up db compat. If you stay on the same one that you have had in your source system, these are not working for you, but not against you as well. And that's the important part right there. So all the new changes are gated to the new compat level. And this is working for you, not against you. This is making sure that you have predictable performance. That whatever queries that you ran with a certain performance profile back in your source system will be optimized the same way when you move to a new system. That's working for you, not against you. Later, when you have time to go and search for potential issues and you essentially go through a recertification process and you say, okay, I'm ready, my workload is now tuned to these model changes and I can move up and I can start leveraging all the goodness that we have put into the higher versions of the db compat, then you're ready to do that with security.
Luckily for the CE, there is a
I'm sorry?
where you can run with the legacy cardinality estimator.
Can you repeat that? Sorry.
There's a flag in the database so that
Yes, there's also that. So yeah, I don't want to get into those intricacies, but once you move higher to the db compat level, that means that by default, all your workload will be running under these new sets of rules and regulations. But you have knobs, ways, hints, and database compat settings, database level settings that allow you to dial back for a specific query, for example. But we'll get to that. And we have tools to help you do that automatically. There was a question there.
Several screens ago, you were showing when you're running the migration assistant tool, the compatibility levels and the issues that you can have within each of those if you upgrade it.
Mhm.
And then you also had the disclaimer that some of the DMVs might have been removed
Mhm.
in version to version. So how can you say that if you go from 2008 to 2016, it's guaranteed to work, where you're guaranteed right in there you're going to have 10 errors?
So you run the tools, and so there are two concepts here, which is why I laid out the concepts of discontinued code versus everything else. Discontinued code means in those old versions, we made a decision, misguided or not, to remove code. So that means that those statements that use that discontinued code will no longer work under any db compat. Okay? So that's what you need to know about them using,
Then how did it work in the old system?
because in the old system they were there. They were discontinued in the new system. In SQL 2012, for example, we removed those fast first row, for example. If you were to run that statement in SQL 2008, it would work. But once you move to SQL 2012, that's removed from the system, no longer works.
So that's a showstopper.
So that's a showstopper for you back then to move from 2008 to 2012. You would have to address those because your code would not work.
Okay, I got it.
It's different from you have a database today that works in SQL 2012, for example. It's working. That's the last version that we really removed code. So let's say your database today is working in 2012 just fine. You will still run that tool because, again, knowledge is power. You want to know if there's anything you need to take care of. But the db compat 110 will guarantee that from a functional perspective, for T-SQL that worked in a certain way back in 2012 will still work that way without breaking changes in 2019 or Azure. That's so.
One other quick question now, when you were showing the different versions of SQL and the compatibility levels that are the default values for each of those versions, you had database as a service and had a
That is not the case. That is not the case. So are you referring to Azure?
It was the same compatibility level as SQL 2014.
You had them available. You are in control of what DB compat you use. So for example, you have a database in SQL 2012.
Unless the DMVs got upgraded.
Yes, so there's no discontinued code.
I can't be guaranteed what works today will not work, that will work tomorrow.
It will, because what works today in a given version, if it doesn't block you from moving to a higher version, that means that in that higher version it will behave the same from a performance and functionality perspective, the same way as it did in the previous engine. We can discuss this offline because there's a few concepts associated with this. Yes, question and then move on.
Not so much a question, but will you cover the process of, if I'm running, 2016 in a compatibility mode with, say, 08R2, and when I try to go to 16, it falls apart completely. How do I figure out what to do to fix it?
So the comment is, I will cover if I'm in 2008 and I want to move to 2016, how do I avoid everything from falling over? Yes, I will. And we have tools actually to do that for you and assist you in that motion. Okay, so just to give you a gist of what the trace flag 4199 encompasses, what you see in this table, which mimics what exists now in the documentation. For example, if you are on Database Engine version 13, which was SQL 2016, if you are using DB compat 100 to 120, trace flag 4199 is off by default, right? But if you move to, so that is this line over here. But if you move the database to DB compat 130 or above, then the trace flag may still be off, but you see here that the behaviors are now enabled, okay? And once you move to 2017, the same. So if you keep these compat levels, those fixes are disabled, but if you move to a higher compat level, the fixes are enabled, and the same for 2019. This is now the table that exists in the documentation since of last week. Now, the cardinality estimated changes follow a similar pattern. Now, the cardinality estimator is the fundamental process to optimize a subquery plan and to create a query plan for your queries to execute. Now, that has a number of models and certain rules that will end up in creating a specific plan for a specific query. Now, the goal is always to generate a good enough query plan to resolve your queries. And that stems from the cardinality estimator process that will estimate how many rows it thinks, based on statistical models, will come from each of the tables that are feeding into that query. Most systems will benefit from using a more modern cardinality estimator process, but as many of you pointed out, you hit pitfalls. And that's what we need to take care of. So there is this risk that if we move from an older version, older than 2014, to a version that's higher than 2014, you have that risk of regression if you haven't done your homework, in essence. So if you see here, the DB compat level, as you progress, we have new cardinality estimator versions. So someone called before the legacy CE. That's what we call CE 70. And that has been the CE level since actually SQL 7 all the way to SQL 2012. After that, in 2014, we released, so with the DB compat 120, there's a 120 CE version. And as you see, the numbers progress in tandem. The number, by the way, it has to do with the SQL Server version. So SQL Server 2019 is 15.0. That's a build number of SQL Server, which is why DB compat is 150, which is why the CE version is 150. SQL 2014 was 12.0, therefore 120 in CE and DB compat. And all this information can be seen in any problem query that you may find. Every query plan that you look at will have embedded into it the information about what was the cardinality estimator model version that you ran with. So you'll be able to see, oh, okay, I ran this, I'm in SQL 2019, but this query is running in cardinality estimator model 70, so AKA legacy CE. So there's some knob that someone turned, some hint that someone used to make it act that way. So I know this is a lot, but these are foundationals to understand all the risks that may be involved in not doing your homework when you move from an older database engine to a newer and immediately turn on the latest DB compat, because there's a lot loaded into the DB compat, which is why it's a lot safer for you to move to a newer engine and keep the DB compat. You don't get into these issues until you're able to test them properly. Yes, question here.
Once you decide to move the knob to low, always also you set the hot fixes enabled for the query optimizer?
Good question. So if the question was, if you move the knob to use legacy CE, if you also move back on the query optimizer fixes?
If you decide to move to the 150, ready for it, then you do also always at that point enable the hot fixes?
Always. So if you decide to move to 150, you are enabling by default all the query optimizer hotfixes that were ever released up until the date that 150, SQL Server 2019, became public, which is in this case last Monday.
The parameter to enable the hot fixes after the base release, should always recommend that you enable that?
That's debatable. There are school of thoughts that would say, yes, always do that. I personally advocate that you should test. When you tested upgrading DB compat, you would test with those query optimizer fixes turned on, even the ones that are post RTM, and see if those work for you. There are others even inside Microsoft that say, no, you should always turn on 4199 only if a specific query optimizer hotfix is needed. My take is a little different because here's what, when we release SQL Server, whatever is vNext, and we move to DB compat 160, everything that we release since 150 to 160 will be on by default. So it's a cycle, as you've seen here. It's up to you.
Really, it's more if you turn on the trace flag and CU1 works fine for you, CU2 works fine for you, you install CU3, all of a sudden you get performance degradation because of something that was released.
Empirically, in my almost 20 years of SQL Server, I've never seen that happen, but it may happen.
Yeah.
I don't know all the workloads. Yes, exactly that. Okay, so we've talked about what's under DB compat. Why is it important to think about these as a carefully studied step instead of just flipping the dial? So, and that leads us to the next stage. So post-migration, yes, you're not done yet because you may either keep the same DB compat and then you're likely done. But let's say your next step is to actually start using the new features. How can you move from a place where you migrated and you kept DB compat? Yes, my current workload is stable, everything is awesome, but there are a number of features that I know under DB compat, like intelligent query processing, that I know will want to leverage, and those are only gated in the highest DB compats. So there's a number of things that need to be done post-migration. It's crucial for you to do, first of all, a first verification whether all your data was migrated accurately. Let's say if you back up and restore, then you're good there. But if you had a logical movement of data, import, export, or something like that, then you need to reconcile and see if you have all your data there and if everything is accurate. But the other point is to uncover potential performance issues. Performance issues that may be there when you bump up DB compat. So this is our recommended process to upgrade DB compat from whatever is your current to your target, which may be, let's say in 2019, the default being 150. Upgrade to the latest DB compat, to the latest SQL Server engine, be that on the cloud or on premises. Keep your source DB compat. Don't touch that yet. That won't be changed for you automatically. That's something that you as a user did, so don't do that. That's essentially what this means. Enable query store. Now, there's a full article on best practices to enable query store. If you're targeting 2016 or 2017 today, go read that article. Basically, if you Google for best practices query store, that's the first hit. Go through that article. It has the recommended settings for something that is essentially a flight recorder for your SQL Server, which is query store, to be able to run 24/7. In 2019, we've changed actually the defaults of query store to be the ones that match exactly that article. Then create a baseline. Your database is already working in the new system. You migrated, you moved your application, you pointed your application there, workload is running. or maybe you want to do this in the test system, so therefore your test workload is running. But the point is create a baseline. After you satisfy that one or more business cycles have run through the database and therefore been captured inside Query Store, if you satisfy that you have your baseline, now it's time to upgrade DB compat. Now, why did I build this baseline? Because after I build this baseline, Query Store will help me in seconds as the workload continues if I actually have regressions. And if I do, then I have a few options. If I migrated to 2016, I actually have a report that I'm going to show briefly later that you can see what query regressions happened, and with just one click, turn back the dial, turn back time, and move back to a plan that worked because you built that baseline. You had a point in time where your plans worked for you, where everything was okay. If you move to 2017 or above, you have this feature called auto-tuning. Auto-tuning includes detecting automatically that these regressions happened and say, oh, I actually have a good point in time back there. I'll just revert back to that and my code will work as it did before. And that's done automatically for you. And we have another option that I'm going to show later, which is a feature that can lead you to a third step. So why do you need Query Store? I've said a little bit about this. Query Store is effectively the flight recorder of the airplane that is your SQL Server. You don't want, or I wouldn't want, well, I don't want my plane to crash, but the point is if you're an airline, you want your black boxes to work all the time. You want your flight recorders to record all the data, to work all the time, so that they can be reviewed. And that's the same here. You want to record performance information about the workload that runs through your databases so that you can, either from a data mining perspective, you want to understand the patterns that run through your workload. Query Store will help you do that. Or you have to react to a performance issue, and Query Store will help you do that. So you need this running all the time, essentially. And as you see on the screen here, this is a screenshot from SSMS. In the scope of each database, there's a tab called Query Store, and underneath there's a number of reports. Now, all of those use, obviously, DMVs inside the engine that you can leverage yourselves in your scripts, and there's a number of examples out there. But you can use this UI here. And notice there's one called regress queries right there that you can manually actually open and see if there are regress queries in whatever period of time that you choose in that report. Or, like I said, if you have auto-tuning turned on, that it does that for you automatically. Now, how would you use Query Store in the scope of the DB compat upgrade? I created my baseline. After I'm satisfied, I bump DB compat, and after that, I go to that report and I start seeing different query plans for the same query. And let's assume that as I'm looking through this timeline, which is just a few minutes in this demo, I find that one plan is consistently better than the other plan. The better plan, perhaps, was the one that was working before I bumped DB compat. The new plan, which is conceivably worse, is the one that exists after I bump DB compat. So this is what constitutes a regression. The new plan in the new DB compat is worse than the previous plan in the previous DB compat. I can select the plan I want, and I have this button here, Force Plan. Done. I've addressed my regression. For that query, I go back to the point in time where that query worked. But this can only work if I built the baseline, which is why I can never bump up DB compat as soon as I move to the new engine. I need to let it build a baseline so that then I can actually find regressions and either manually like this or with auto-tuning in 2017 and above, just do this automatically. So yeah, and I can click, and these reports allow me to explore a lot of things. For example, for every query, I can explore all these dimensions here. Duration of the query, CPU time, logical reads, degree of parallelism, the memory consumption, the row count, the weights. There's a number of dimensions here that I can explore and even understand why has this regressed. Now, I fixed it because I forced the good plan, but that's on the old DB compat. I want this query to work better with the new DB compat. I'm taking the query text, taking the plan, go to my dev system, go to my devs, or I have a test system. I'm going to tweak the query to work better with the new DB compat. That's why new developments work under the new DB compat. And then I deploy to production, and I can enforce the plan and let SQL Server take over. There was a question there.
We have ERP systems
So the question is there a way to force push plans to our customers if we're working remotely with them? Well, each system is different, so you need to understand if you want to force certain plans or not, right? The other point is that unlike a plan guide that you can say, oh, here's the XML that you always use, the show plan that you always use for this query. This is based on the discoveries, the findings that this query store for this database has. So it's only in the scope of this database that I can force a plan or not. And the same query may have a different ID in this database versus the same database in some other server of some other customer, but that query may have a different ID, right? So it's not programmatically useful like that. However, in 2017 and above, we do have auto-tuning that I highly advise to be turned on because it will detect regressions like this automatically, correct them automatically, and you still have the power to go to a certain DMV, seize the MDB tuning recommendations, and you see what happened. So you come in the morning or after a week, and you look at that DMV and say, oh, that query was actually regressed, and the system took care of that. But here's why it regressed. It turned from X millisecond CPU to XY millisecond CPU. So you still have the power to see what happened. It's just that no one picked up the phone and called you in the middle of the night because auto-tuning did that for you. Okay, so this is the feature that I was talking about. So essentially, imagine a timeline. And the timeline here is, this is my baseline working with DB compat. Let's say this is an upgrade from 2008 to 2019. This is my DB compat 100 working fine. Then I bump up DB compat. And a few queries regress, and obviously I see worse performance here. If I have auto-tuning turned on, and because I built my baseline, what happens is, it detects that condition. It detects there was a previously known good plan. It forces that plan, and you're fine. You no longer have a regression. Let's do a quick demo on this, just for you to see how quickly it reacts. I have, can you see my screen? You can, okay. So I have this app here. Hopefully live Zoom will work for me. So this is a reporting app that a lot of my users in my company use. And I just moved my database from SQL 2008 to SQL 2019, and I kept DB compat 100. So my expectation is that I have the same throughput as I did in my source system. There we go. And so this is my laptop, so bear with me. 60 batch requests per second is not a lot, but just for comparison purposes. So I have a stable workload that's running in my new system under the previous DB compat, so everything is stable. I run through my business cycle, whatever that is, if it's a week, a day, a month for you. And then I'm ready to bump up DB compat. And when I bump up DB compat, it so happens that changes in the CE may introduce regressions to parts of the workload. And you see here that throughput decreased. Now, this is what would happen, for example, moving to 2016. What would I do here? I would go to the database, open query store, go to that report, find which queries regressed, and start manually, furiously clicking on force plan. Or, in 2017 or above, you have auto-tuning. And auto-tuning would do this for me while I was resting at home. And it goes back to the previously known good plans for the queries that regressed, and performance is restored. Just like that. Any question? Yes?
Does it notify you that it did this in case you want to go back and do some?
So the question is, does it notify that it did this? We need to define notification. There's no pop-up or anything like that in SMS that tells you this happened. However, there is a DMV, the MDB tuning recommendations that will tell you what queries regressed. And if you want to actually track in real time, there are X events that you can be running in an X event trace. For example, in the period after you move DB compat. If you want to then later analyze that, then run that X event trace with those X events documented, and you will see the moments these auto-tuning kicked in to protect you from these regressions. Yes.
Auto-tuning depends on query store?
Yes. The question is, auto-tuning depends on query store? It does.
Like have to have query store enabled?
Absolutely. You do have to have query store enabled to be able to do this. Question?
So if I understand you correctly, in 2016, I go and do all sorts of testing in my staging
So the comment is, I've done performance testing in a UAT environment, and I can transfer.
I mean, I go through and I find all the things that it tells me I need to fix. I go through and I fix
Got
it,
it.
and I'll do all that stuff.
Oh, I see.
Then I go to production. I have to start over because I can't transfer any of that knowledge.
So the question is, could I essentially transfer query store data from my test system to my production system and leverage whatever actions auto tuning took for me? Is it?
Well, because at 16 there's no auto.
Yeah, and that's true.
It's all done manually.
Yes. So the simple answer is no. But here's the thing: if you have taken the time to test and you've seen regressions, then the logical action in my mind would be actually tune the query to not need to go back to the old DB compat. This is a reactive feature, meaning you place it into production and you again, cowboy style, you just bump up DB compat. He didn't do that testing in production. Just what I did is, okay, I'm moving my database to 2019, and okay, I'm maintaining DB compat just for that to build the baseline. And then, yeah, I didn't have time to do any testing, so I'll just bump up DB compat and auto-tuning will work for me. It will work for you on that system alone. Now, if you back up that database and restore it in some other system, query store goes with you. But it's a reactive system, if you will. Another question there, and then we need to move on.
So in a sense, it's not so much about tuning, but about stability.
Yes, in essence. Now, the reason it's called auto-tuning is because in Azure, for example, if you move there, under the umbrella of auto-tuning, there are other features. For example, we can automatically manage your indexes, creating and dropping indexes depending on whether they help the performance of your workload or they actually have a problem, represent a problem for your workload. So auto-tuning in SQL Server 2019 and 17 mean this feature, automatically planned regression correction. That's what we call it, APRC. But in Azure, it has the added dimension of also being able to tune your index design according to your workload as it progresses. So that's why you call it overall auto-tuning. And we're working on other features to put under this auto-tuning umbrella. The idea is that you have a self-healing database, if you will. Okay, so let's carry on, because one of the approaches was this one. I just trust on the features to react to the issues that were found after I changed the DB compat, and it just goes back in time for me. Now, is there another approach? What if instead of choosing between the current plan or a last known good plan, you could actually try to find a third way, a better plan that works without necessarily going back to legacy cardinality estimator, but works best on your new system with a newer cardinality estimator. Now, this is where the query tuning assistant comes in. Now, the top priority of Query Tuning Assistant is to guide you in a wizard-like fashion through the recommended DB compat upgrade. Now, you could do all that manually, like we've seen in the last few minutes, but this tool, QTA, will guide you through really upgrading DB compat. But the last step there, which is quickly fix regressions by forcing the last known good plan, is replaced by this. Find a better plan for this query that regressed through tuning that query. And that's where QTA comes in. So the Query Tuning Assistant has a specific workflow, and the workflow is it also sits on Query Store, so it requires Query Store. It requires Query Store's ability to detect queries that regressed. And then, on those queries that regressed, it will actually experiment on them by actually running those queries. Now, one caveat here, this only works with select queries, with read queries, because we're actually going to run them. So it kind of becomes obvious there. We still haven't figured out a way to test your updates, deletes, and whatnot. You can, if you're in the UAT system, it should be simple enough for you to pick up those heavy deletes or updates that have where clauses and whatnot. Just turn those into selects, even run manually while the query store is collecting its data. And those are also stored there, and then they'll also be analyzed by QTA. That's one way of doing it. So the QTA surface area, what it does is it will test your queries for these known areas of regression when you bump up DB compat and therefore move to a new CE level. There are these areas that we've come to understand through working with a number of customers in the last few years that for certain workloads represent the heavyweight of reasons why queries regress. So that's exactly what Query Tuning Assistant is looking for. It will look for patterns that match those potential regressions. And if it finds them, it will experiment with those tweaks turned on. And if it actually gets a better result, it will then give you a recommendation saying, hey, I've actually found that this knob here, if you add it to your query, it will tune it and you will have a better performance. And then in the end, right now in this version, what it does is you can do two things. Either accept the recommendations and deploy them to your database as plan guides. Or B, see what it recommended, and you take it and you do it manually in your code. You can do it both ways. Now, doing with the plan guide is useful for code that you don't own, for code that you can't change. Because what it does is, you don't change your code remains the same, but through a plan guide, you actually have the ability to inject knobs, to inject hints. So what it means is your application sends in code, SQL Server recognizes that code, oh, this matches that plan guide, I need to execute it using this knob over here, so it executes in that optimized fashion and you didn't have to change the code. If you can change the code, then by all means do it. So let's see how I can upgrade the database using QTA, so to guide me through the process, and at the same time, find regressions and handle them. So this will be an accelerated version, obviously, because I have just a few minutes. By the way, these demos are available right now in our GitHub, but I'll make the deck available in the past website, and that has links for the demos. So let me try to bump this up. I have my AdventureWorks DW 2012 database. So what I have here is that my application was certified for SQL 2012. It worked fine then. And now I want to upgrade that to SQL 2019. So I have here my SQL Server 2019. And I've already restored my database here. I'm still not running anything. So the database was just restored. And if you go and look at the properties, you'll see that the DB compat level remained at 110, which was the default back in 2012 when this database was created, right? So by restoring the database or attaching, that doesn't change. And I will want to change it because I have I have a fixed goal of upgrading the database compatibility level, but I just don't want to do it right now. So here's what I'm going to do. I'm going to use SSMS itself to guide me through that recommended process to upgrade. How? So I'll try to bump this up. I'll right-click the database, go to tasks, and I have a new option down here. By the way, this is available in V18, SSMS version 18 or above. Now we're in 18.4, if I'm not mistaken. So you have this task here that says database upgrade. First thing I want to do, I want to start a new database upgrade session.
Before you go, I just want to make sure that this is not happening in production. I don't think maybe you restored database staging.
Yes, by all means. Do that. You can do this in production. It's really up to, no, honestly, it's really up to you because you can do this in production and I've had customers doing that, but just not in peak times. Like you have a way to have a few users standing behind and doing their usual workload in the evening for you to capture it, or you've captured it before. I mean, they have a way to replay it. Not everyone has a UAT server, although they should. But if you have a test server that you can replay your production-like workload there, then by all means do this process in production. Sorry, in the UAT. So what I have here is that this wizard comes up, and it starts by asking me a few questions because one thing it needs to do is configure query store to capture at least one full business cycle worth of workload to create that baseline, right? So it asks me, hey, what's your workload duration in days that I need to capture? And you'll see why this is used. Let's say my workload duration is 2 days. What is my target DB compat? So my database is at 110, so it shows me all the higher DB compat levels that exist above the current in my 2019, which in this case goes from 120 all the way to 150. Yes, I want to move all the way to 150. I want to use intelligent query processing, everything. Okay, next. Now the next thing is query store. Now, here are the current values of query, the current configurations, settings, and status of query store, and here are the recommended values. Now, if you already enabled query store and you have if you have the settings that you know that work in query store for that database, just select current and let it be. If you don't want to take the recommended, but you want to change something, again, move to the current and change whatever you want to change and go ahead with those. Or simply take the recommendation. So the recommended, why did we ask before about the number of days that my workload would take? Because of this here. So one of the settings in Query Store is the stale query threshold. That means that queries that have executed for more than that time are considered stale. So for space-saving purposes, they will be aged out and removed from Query Store. So I want to make sure that I can collect my entire baseline inside Query Store. So that means that I need to be able to hold in Query Store the amount of information so I need to not age out queries that are not older than the days that I've set before. And why do I have 4 instead of 2? Because I need to build my baseline. Let's say my baseline takes 2 days to build. And then if my baseline, my full workload took 2 days to run, to populate my baseline, that means that after I bump up DB compat, I'll probably have to wait up to 2 days for, again, my full workload to run and really identify all the regressions that may have happened with all the workload. So then I have a true comparison between business cycle before upgrade, business cycle post upgrade, and that's when I can start running and doing comparisons. So when I click next and I accept the recommended settings, it tells me, awesome. So you've now ready to begin populating Query Store with workload data. By the way, this doesn't do it for you. You need to have your own ways of running your workload. We don't know what your workload is. So you now start in your UAT server or something like that, start running your workload. Which is what so I click finish, done, gone. So that's what I'm about to do. I'm going to run my pre-upgrade workload. There you go. So this will take like a couple of minutes. And while the workload is running, let's assume my 2 days will work in the next 2 minutes. I can come back I can close SMS, go away, and at any point I can return, right-click, go to tasks. Let me bump up this again. Task, database upgrade, and now I go to monitor sessions. When I go to monitor sessions, I see the session I just created, the tuning session I just created for this upgrade. And it yes, select a session that you'd like to resume. Okay, I click on it. The status is active. It started right now. Details. Thank you. I was getting lost here. Okay, so what you see right here is basically a timeline of all the steps that will be running in this recommended upgrade procedure. So step 1, baseline data collection. If you're not started already, execute your representative workload. That's what I'm doing in the background. Once you're done with that workload, come back to this. So you can close this and go away and come back after 2 days, 10 days, whatever you set. Come back to this screen and click on I'm done with the workload run, which I'm not sure if yes, I'm done. So I'm done with my workload run, so I'm going to click next. And now it tells me this. Okay, you're about to upgrade DB compat to whatever target you chose. In this case, was 150. Do you want to do it? Well, yes, that's what I want to do. So I click yes. It tells me yes, you've upgraded successfully to the latest DB compat. And now this is just the beginning of the process. Now, as I click next, I now see already a few queries here. And what it tells me is that, hey, I've observed that you upgraded to the desired compat level. Now you need to go and rerun the same workload as you did before so that you can now have a comparative workload for the baseline. Okay. So I'll go back. I'll run my post-upgrade workload, which is the same. And again, it will take a couple minutes. And then I need to wait for it. And then again, click on done with workload run, and then I will click next. So let's wait for a minute or so. That's what it takes. Any questions so far? Yes?
In the real scenario, I mean, we cannot run the
Then I would suggest you have a way to not run this in production, but run in your test system and be able to run those consecutively.
That's another thing. I mean, no matter, I don't know if people here, but no matter how much they say it's UAT, it's never production. There always is something
Agreed.
which will be in prod and not in UAT.
It may. So here's what. I'm using this to uncover and tune as much as I can before I actually do it in production. And then in production, I have auto-tuning working for me, because I will repeat the step of, in production, moving DB.
In QA for sure, but I would also like to do that in prod. I mean,
Well, it's really up to you.
that there will be some queries which are not, some process which does not work in QA.
And then what you're telling me is that, yeah, my UAT environment is not really trustworthy, so I have to do this process in production. And you can. There's nothing stopping you. Be careful about the time. Don't do it in peak time, but otherwise, you can do it.
So really viable to do it in 16 where you have to do it all manually?
Is there a way to determine what should be the size that I can keep and just
That is something that is dependent on the workload. Purely dependent on the workload. If you have very intensive workload, very diversified, query stall will grow faster than not. So there's no magic number there.
but it just reports the query class.
In the interest of time, let's do this offline. I'll just finish the demo so that these fine people can start leaving. So I'm done with my workload run, so I'm going to signal that next. And it populated this with a number of queries. And a few of them, and I have the performance metrics for those queries here. So I see the baseline metric. So this query, for example, ran in 83 seconds, and after I bumped it, DB compat took 77 seconds, so that's good. But I have a few queries here that regressed. So in any case, the list could be enormous, so I could go and look at every query. For the interest of time, I'm just going to select all of them, click next, and what I do when I click next is I start the analysis phase. I will take all the regressed queries and I'm actually going to run them. Again, only select queries, only parameterized queries. We'll run them, get actual execution time data, and then make a call which tweaks I must do to improve the workload. So yes, I'm going to do this. And as you see here, in this case, we're very fast. It shows test complete for every one of these queries. And what I see here is that this is the original baseline metric, and this is the observed metric after I applied a specific tweak. And I'll let you know what tweak that is. So I can see that a few of these queries improved by 70%, 100%, 62%. It's tangible data here. So I actually have tangible improvements that were tested, and I know that if I use these knobs, these tweaks, my query will be better. So for example, I want to know what query option I'm using here. So for example, I can click on this one, and that actually opens, it opens the, sorry, what is that? Not this one. It will open the documentation page on the area of the tweak that I'm using. For example, this one, what it's doing is moving back one of the assumptions that changed between the C70 and the newer version of the CE. But instead of me having to go full-fledged back to the previous version of the CE, I'm just tweaking one aspect of the new model, still leveraging all the goodness that's in the new model, but that one was not working for me. I'll tweak that one back to the old model, and as we've seen here, for this query, actually this one was not good. So I have all these here. I could go in each one and see whatever I need to do manually, or B, I can select this and deploy the plan guides. I see the status is deployed. Now, these are all working through plan guides, but somehow, even after this was based on tangible data and tangible tests, it started regressing again. So I can come, this has all been closed, I'm coming back a few days later, I open the session, I click on this one, for example, and I click rollback. What this did was it removed the plan guide. So now the engine is doing its stuff again. And maybe I need to tweak the query in some other way. But I was able to roll back a deployment of a supposed improvement that then after a few days was not an improvement anymore. Yes, there's a question. I need to actually,
Just real quick.
yes, go on.
On this, when you did select all and you applied it, you deployed it, did that minus 788 actually deploy?
Yes. So that's a case. That's a case that I can actually come here, roll back, done, gone. If you selected everything, let's say the list here at 200 queries, and you didn't go through every single one to select which ones you wanted, you just selected all of them, but you can come here after the fact and undo what you just did. Yeah, you can do a number of things. So in the interest of time, I just have a couple more slides I want to show you. So the modernization tools breakdown, if many of you were in Pam's session, which is good, so you've seen a number of tools that we have, DEA, DMA, now with QTA here. So they all serve very different purposes. DMA, you will test whether you have any issues that block you from upgrading to a new system. The DEA you'll test if you want to do A/B testing. Actually try to anticipate what performance gains or not I'll have from moving from an old version to a new version. And QTA will help you uncover tuning opportunities in your workload before you move to the new compat level and assist you in that motion. And yes, by the way, if no one asked, but there's also auto-tuning here. Auto-tuning uses query store as much as QTA uses query store. They both detect regressions. The outcome is just different because in this one, auto-tuning, I'll go back to a previously known good plan, whereas in QTA, I'll try to find tweaks that I can apply to get a new, better plan working natively in the latest version. Yeah. And then there's DTA and QTA. You can review this one later. So DTA being the database tuning advisor that you've probably known for years. And how does that differ from QTA? You'll see right here. Because the surface area for DTA is to look at your indexes, statistics, index views. And QTA actually looks at your queries and tries to tune them with some knobs there. So you have a few links here. There's a number of demos around 2019 that we've put already in notebooks. Some of you saw notebooks this week. I talk a whole lot about the potential problems, a lot more than we did here, of upgrading databases and the CE upgrade and how to use these tools in this book. So shameless plug, we got to do this. So all these tools that we mentioned here are also covered in that book. And yeah, thank you very much for your time today.